So next now we have multiplication rule for probability. Addition rule, addition rule for probability is for probability of union of two events, which P of A plus P of B minus P of A intersection B, which we have discussed earlier even in 11th standard. Now multiplication rule is for probability of intersection events, that is P of A intersection B. Addition rule is for union, whereas multiplication rule is for the probability of intersection of the two events. So here we start with two events. Let's take events B, E and F. We are given these two events. Then the probability of occurrence of both the events, that is E intersection F, is given by probability of E into, now which event has already occurred? Event E has already occurred. So the probability of occurrence of the next event F may depends upon the already occurred event. So we will have here conditional probability. This is defined as multiplication rule for the probability, product rule for the probability. What it says? There is a concept of conditional probability here. The event E has already occurred. The second event, the occurrence of the second event may depends upon already occurred event. So we have here conditional probability. You can just rewrite like this also. This is equals to, suppose event E has already, F has already occurred. Event F has already occurred. Then the probability of occurrence of next event E may depends already occurred event, that is F. This also we can define the multiplication rule for probability. It just comes from definition of conditional probability. What's the definition of F given the event E? We know it is P of E intersection F upon probability of E. Now you just make this as a subject of the expression. So you have here P of E into this. That's what I've written indirectly. So it just comes from the definition of what? Conditional probability. So either we have this, or probability of both the events E intersection F is given by this. If we take three events, let me write, this is called multiplication rule. Multiplication rule for probability. Rule for probability. Okay. Even for three events, if I consider three events, let events be this here. Events, I'll consider E, F and G. There are three events. How many events? Three events. For these also we can write multiplication rule like this. So multiplication rule means occurrence of all the three events, E intersection F intersection G. This is equals to here probability of E, that is event E has occurred, into the probability of F, which depends upon already occurred event, which event has already occurred, that is E, into, now how many events has already occurred? E and F both. So probability of the third event depends upon already occurred events. Which events has already occurred? That is E and F. So E intersection F, like this. This is multiplication rule for three events. You just write the formula for this, you will see that all will get cancelled internally, you will get just this much. So this again just comes from the definition of conditional probability. Right? This is multiplication rule for how many events? Multiplication rule for three events. Three events, E, F and G. If I take one simple example which is just related to this. Suppose there are 52 cards. We are selecting two cards one by one. We are selecting 2 cards one by one, say without replacement, without replacement. What is meaning of this without replacement? That means one selected card is not placed in the box. Then what's the probability? That's the question. So required probability here, indirectly we are going to use this multiplication rule. You are selecting one card out of 52. So what's the probability? 1 upon 52. So that is this, P of E or P of F, whatever you write it. Probability of getting one card out of 52 cards is 1 by 52. Now we want to select the second card because we are selecting one by one 2 cards. Now when you draw the second card, without replacement means that selected card is not placed in the box. So you are left with how many cards now? 51 cards. So what's the probability of getting one card out of 51? That is 1 by 51. So you see, it's a concept of conditional probability. The probability of the second event is now affected by already occurred event, that is 1 by 51. So this is indirectly nothing but this multiplication rule. I have not written symbolically, but if you find this 1 upon 52 into 51, this gives us probability of getting 2 cards one by one without replacement. What is important one to note here is this probability of the second event is affected by already occurred event, that is 1 upon 52. Fine. So indirectly I've used the multiplication rule here, and probability of the second event depends upon already occurred event, so it becomes 1 upon 51. That is one thing. Okay, now next concept is about independent events. Let me write that. So here next definition let me write, which is about independent events. Independent events. So for that again I'll go back to that same example. Let me write that, you will realize what I'm trying to tell you. We take out of 52 cards, there are 52 cards, 2 cards are selected, 2 cards are selected, one by one with replacement. Okay, what was there? It was without replacement. Here what I am saying, with replacement. What is the meaning of this? You select one card, then again you placed in the same total cards before drawing the second one. That's the meaning of with replacement. So in this case you see the required probability equals to, what is the probability of getting one card out of 52? 1 by 52. Fine. Now when I draw the second one, I must have to place that selected card again in the box. So if I have drawn, you were left with 51, but if I again put there, when you draw the second one with replacement means when I draw the second one, the first selected card I already placed in the box. So when I select one again out of total 52, the probability is again here 1 by 52. So here the probability of the second event is not affected by already first event. So if this is P of E, for example, then here the probability of the second event is not affected by the first event. So it is just P of F. Right? In earlier case it was P of E into P of F over E. This was the conditional probability. But now this conditional probability becomes what? Just F of P of F, remember. You see here you had this conditional probability. So here it is 1 upon 51, but here it remains again 1 upon 52. So these two are equal. This conditional probability of F over E is just P of F. The second event is not affected by already occurred event. So such events, when the second event is not affected by already occurred event, then such events are called independent events. Independent events. Independent events means what? The probability of the second event is not affected by already occurred event. Now how do we write symbolically? We just write like this here: two events E and F are called independent events, are called independent if this is true. What should be true? You know it. Probability of intersection E intersection F equals to probability of E. Normally in the multiplication rule, if nothing is given, then here you have conditional probability. But if this event is independent of already occurred event, then this is no more conditional. It is just P of F. So if this is true, then such events are said to be independent events. So whenever you are asked some examples, check whether events are independent or not, you just need to check this condition. Find the probability of intersection. See that this is same as their multiplication. I hope this is clear to you. What's the difference? This is no more now conditional probabilities, just become P of F. That's what I've written. This just comes from where multiplication rule. But now being independent, this becomes just P of F. Fine. Finally, you need to remember this. Whenever two events are independent, then P of E intersection F equals to P of E into P of F. If you ask such questions, check whether events are independent or not. You need to verify this much only, nothing more than that. Clear? Okay. Now, before I get into next exercise, there is a result based on this. Let me state that, which is about independent event, which we use effectively. Result is this. If E and F are independent events, if E and F are independent events, E and F are independent events, then there are three results. E and F dash are independent. E and F dash are independent. Second one, E dash and F are independent. It can be proved also, not a big task. And the third one says E dash and F dash are independent. You know complementary events. Dash means you have complementary event. E dash and F dash are independent events. Are independent events. What is this result? This is a very important result. We'll use it even in examples. This says that if given two events are independent, then their complementary events are also independent events. So E and F dash, E dash and F, and E dash and F dash are independent events. Fine. And we use these also in example to check whether events are independent or not. Instead of intersection, we write multiplication. So with this information, now we'll go to next exercise, which is exercise 13.2. So let's start with that. Exercise 13.2. Question number 1, first question. Check whether events are you are asked to find intersection if A and B are independent. Okay, so you are given P of A, how much? 3 by 5. P of B, 1 by 5. You are asked P of A intersection B. So you can write P of A into P of B. Why we could write this? Because you are given that events are independent. Given that independent events. Otherwise we cannot write this, remember. Intersection is replaced by multiplication if events are independent. That's given in the question. Okay, so just place the value 3 by 5 into 1 by 5. So it is just 3 by 25. Required probability. Question number 2, second one. Two cards are drawn at a random without replacement. Now you know the meaning of word without replacement. So we have 52 cards here. Two cards are drawn. Two cards are drawn without replacement. Without replacement. That means selected card is not placed in the box. Find the probability that the both are black colors. Both are of black color. Right? So I'll write like this. Let B1 be an event that one by one you are going to select. When you have word without or with, that means you are not going to draw two randomly, one by one. Event that first card is black and B2 be an event that second card is again black. Fine. What is the question? Please read the question carefully. Question is, find the probability that both the cards are of which color? Black color. I have called these two as events B1 and B2. So required probability will be here. So required probability equals to both. Remember, both means intersection. So you want this B1 intersection B2. So probability of B1 into probability of B2, that depends upon already occurred event, which is B1. Which rule I've used indirectly? Can you recall? Multiplication rule. See, here I could replace direct intersection equals to into. Why? Because events were independent. Here in the question you are not given that the events are independent. So you have to use the multiplication rule. B1 has occurred first. The probability of B2 depends upon already occurred event. So you have this. Now you write these two things which you already written without symbols earlier. What's the probability of B1? That this card is of the black color. That you know very well. How many black colors cards are there? 26 and total 52. So 26 by 52. Probability of the event that the selected card is of black color. One card, remember. Now without replacement means selected card is not placed. So total you are left with now 51. One you already selected. So you are left with here how many cards? 25 cards. I repeat. This is done without replacement. One black color card you already selected. So you are left with how many black color cards? Second should be also black color, remember. So here you have how many black color card? 25. Out of total 52, one you already selected and you are not going to place. So here you have total 51. So let's simplify this. This is just half. So 1 by 2 into 25 by 51. So required probability will be 25 upon this is 1 not 2. I hope this is clear to you. This is a concept of conditional probability here. Let's see the next question. That's really good question. See, 3 oranges are selected without replacement. Now when you have word with or without replacement, that means 3 are not selected randomly, one by one, remember. You select one, then second one and then third one, like this. One by one 3 are selected. It is understood when you have word with replacement or without replacement. Total how many oranges? 15. There you are given the question, 12 are good, 3 are bad, not good. Okay. Find the probability that a box containing 15 oranges, total 15, out of which 12 in this, which will be approved for the sale. Now what is the condition for approval of the sale? The box will be approved if all the 3 oranges are good. That means all 3 should come from 12 only. All 3 are good, then and then the box will be approved, and you want the probability that the box will be approved for the sale. So I'll write required probability equals to all 3 should come from this 12 only. then and then the box will be approved for the cell. So you want to select one only. How many good? 12. So 12 favorable outcome. Total how many oranges? 15. There is a probability that the first selected orange is a good one. And now this is a multiplication rule. Selected one is not the placed. So now good one how many? Out of 12, one you already chosen. So here 11. Total out of 15 it will be 14 because selected one is not placed. You see the condition here without replacement. So you are left with 11 good and total 14. 2 oranges you already selected, 1 and 2. Now turn comes to third orange. The third one also should be good one. But out of 12, 2 you already taken. So now you are left with 10. Out of total 15, 2 you already taken. So here we are left with 13 good 13 oranges total. So this is the required probability. This is symbolically it's like this. If I write orange event, for example, O1, then this is P of O1, that is the first orange is selected, into second orange O2, which depends upon already occurred event, that is O1, into the third orange, if I call the O3, then that depends upon already occurred events O1 intersection O2, like this. Symbolically it is this. I have not mentioned here symbols. The important one is this. But this should be clear to you. Why 12 by 14? Why I have taken 12, not these 3? You read the question. You are given that if all the 3 oranges are good, then and then the box is selected for the cell. And you are asked find the probability that the box is approved for the cell. That means all 3 should come from these only. So when you take 1 out of 12, it is 12, total 15. When you take 1 already chosen, now you are left with 11, total 14. 2 you already selected, so now you are left with 10 and the total 13. Just simplify this. So here, if you simplify, let me write here 5 3s and 5 2s. Over here, this is just 3 4s. So 4, this is 7 and this is 2. So 2 11. So it's 44 and 13 7s, which is 91, which is a required probability. I hope you are clear with this. Fourth question. Check whether the fourth question, we want to check whether events are independent or not. So we just need to check whether A intersection B equals to P of A into P of B or not. This we want to check whether they are equal or not. If equal, then independent. Not equal, then not independent. Now what is definition of event A? Event A is nothing but H on the coin. H on the coin. So therefore what is probability of A? You know, total head and tail. So 1 by 2, 50%. What is definition of event B? Event B is nothing but what? 3 on the die. Now die has total how many outcomes? 6. Only 3 means 1. So P of B is nothing but what? 1 by 6. It has, you know, total 1, 2, 3, 4, 5, 6. Total 6 outcomes. And there 3 only. So you have 1 by 6. Out of 6, 1 only. So 1 by 6. Event B. Now we want probability of A intersection B. A intersection B. Now what is the meaning of this? H on the coin. Both. Occurrence of both. So head on the coin and 3 on the die. So how many ways this can be done? So there actually sample space will be this in this case. When you take both, that is coin and die, then it will be like this: H1, H2 up to H6, then T1, T2 up to T6. So total how many outcomes here in a sample space? 12 outcomes. So upon 12 here. And occurrence of 3 and coin. So here you have like H3, here T3. So 3 and in coin H, so only one outcome. So here it is 1 by 12 because of this. Fine? Is this clear to you? See, when occurrence of both, then you have total 12 outcomes. H1 to H6, T1 to T6, so n equals to 12. Occurrence of both means what? There should be H on the coin and 3 on the die. So there is only one outcome, that is 1 by 12. So finally what we are getting, if you use this 1, 2 and 3, you can see that the P of A intersection B equals to P of A into P of B, and both are nothing but the 1 by 12. And therefore events are independent. Events are independent. Events are independent because the intersection equals to into. Okay. What about next? Next is the same question. I'll not do. So question number 5 for you. Try same way. Same thing you want to check. Do it. I'm sure you can do it. Sixth question. Everything is given. And that sixth you can just answer directly without using just pen. Everything is given. Check into equals to intersection or not, which is quite obvious. Okay, so we just go to question number 7 directly. The seventh question, you are given P of A for event A, which is 1 by 2. P of A union B also you are given, which is 3 by 5. P of B you are given small p. Now you want to get the value of P, that is probability of event B under these two cases. What is the first case? They are mutually exclusive. The first case, if mutually exclusive events you are given. Mutually exclusive. What is the meaning of mutually exclusive? Their intersection equals to 5. We did it. So what is the probability of A intersection B? It will be 0. This is the meaning of exclusive events, mutually exclusive. Intersection equals to null set. Okay, now use addition rule. P of A union B equals to P of A plus P of B minus P of A intersection B, which is 0 here. Union how much? 3 by 5. P of A how much? 1 by 2. So from this we'll get the P of B, which is small p actually. So small p equals to 3 by 5 minus 1 by 2. So how much we'll get? Here 6 minus 5, which is 1 upon 10. So small p is 1 by 10. What is the second sub question there? Second sub question, independent events. If events are independent. Independent events means what? Intersection becomes into. So whenever you have intersection, just write P of A into P of B. Therefore, you have this information. Now again go to addition rule because you have information about union. So use addition rule. P of A union B equals to P of A plus P of B minus P of A intersection B, which is P of A into P of B. Fine. Now what is union here? Union you are given how much? 3 by 5. What is P of A? That's given to you half. What is P of B? Small p. What is P of A? Half. What is P of B? Small p. So you just simplify, so we'll get the value of P from this. The question is, what you need to do? You just need to simplify. So we'll get the required answer. Eighth question, which is very basic question. P of A 0.3, P of B 0.4, and events are independent. So intersection becomes into. This is given to you in the question itself. Whenever you have intersection placed by multiplication. Okay. So we use this. What is the first question? A intersection B equals to P of A into P of B. Why we could write this? Because this given in the question itself, events are independent. So 0.3 into 0.4. So we have 0.12. Second question, P of A union B, which we did in the previous question. First use the addition rule. P of A plus P of B minus P of A intersection B, which I'll write directly multiplication. You know everything on the right hand side. Place the value and simplify. That is your answer. Third sub question. You want this conditional probability. A given the event B. Now you know if events are independent, then this is just simply P of A. We already discussed. Or you can use the formula. You will get the same answer. P of A given the event B equals to P of A intersection B upon P of B. You know this. Now intersection is replaced by multiplication. So here this is P of A into P of B upon P of B. So probability of B will get cancelled. So what will get here? P of A. That's what I've written. And P of A, you know, it is just 0.3. So that is your answer. Same way, fourth sub question. What about fourth sub question? Probability of B given the event A. So this is P of B intersection A upon P of A. You can just put the value. So finally it is just P of B. And what's the probability of B? It is 0.4. Fine. You can just put the value of intersection and you can notice this. So these are 4 sub questions here. Okay. Next, 9th question. That's also a good question. You are given this P of A 1 by 4, 1 by 2 and intersection is 1 by 8. What is asked? You are asked that not A means A dash and means intersection B dash. We want this probability of A dash intersection B dash. We did such things in sets also. When we have both complement, then we use De Morgan. So I can rewrite as A union B the whole dash. This is by De Morgan's. If you take complement inside, it will be this. This is what you are asked. Not means complement, and means intersection, and not B means B dash. This is De Morgan's. Now these I can rewrite as 1 minus P of A union B. Which property? Recall this. P of A dash equals to 1 minus P of A. We have used this property. You imagine this is like set A. So probability of A dash equals to 1 minus probability of A. That is this one. Okay. Now, very simple for you. Just use the addition rule. What is that? P of A plus P of B minus P of A intersection B. You know 3 values. 1 by 4 here, 1 by 2, 1 by 8. Place the value and simplify. So you will get the required probability. Next question. Question number 10. There again you are asked check whether events are independent or not. What is given? P of A you are given how much? 1 by 2. P of B. What is P of B? 7 by 12. And one more. P of not A or not B. That is A dash union B dash. This is given to you. Equals to 1 by 4. Just compare with the previous question. There you have AND, so you wrote intersection. Here you have OR. You know this OR stands for in general union, N stands for intersection. So here you OR, and not means complement. Remember dash. Okay. Now you want to check whether events are independent or not. So you need information about intersection. So here, like this concept, I'll use De Morgan's. So this is A intersection B the whole dash equals to 1 upon 4. A intersection B the whole dash. This is De Morgan's sets concept. Okay. Now as we did here, you imagine this is like one set A. What is P of A dash? 1 minus P of A intersection B equals to 1 upon 4. P of A intersection B whole dash. This is 1 minus P of A intersection B. So from this you have 1 minus 1 by 4 equals to P of A intersection B. So this will be 3 by 4 equals to P A intersection B. And what is their product? What is P of A into P of B? We want to check whether these two are equal or not. What's the value of this? 1 by 2 into 7 by 12. So this is how much? 7 by 24. 7 by 24. So what is your conclusion? Immediately your conclusion is these two events are not independent. Here this is 3 by 4, here 7 by 24. So from this and this, you can say that the P of A intersection B is not equals to P of A into P of B. And therefore A and B are not independent, They are not independent. Fine. In 11th question, P of A is 0.3, P of B is 0.6. Events are independent. So A intersection B becomes P of A into P of B. This is also given. You are asked for probability of A and B. And means you know intersection. So P of A intersection B. Events are independent. So P of A into P of B. Just place the value and simplify. What's the second sub question? In the second sub question, you are given P and not B. This and not B means B dash. This is what you are asked. Now, you already stated this. If A and B are independent, then A and B dash are also independent. So here intersection becomes into. Why? Because you already discussed one result. If A and B are independent events, then A and B dash are independent. There are 3 sub questions, but one was this. We already discussed. So A and B dash are independent. Why A and B dash are independent? Because in the question itself you are given that A and B are independent. So here instead of intersection I could write multiplication. Otherwise I cannot write remember. Now P of A, you know what is P of A? 0.3. How do you get the P of B? 1 minus P of B. This is a very basic result. We know it. So P of this is 0.3. 1 minus P of B. P of B you know 0.6. So this will be also 0.3. So we'll get the 0.09. Fine. Third sub question, P of A odd means union, P of B. That you know very well. P of A plus P of B minus P of A intersection B. This is addition rule, but that intersection becomes into. We know it. That intersection becomes into. You know these 3 values. So place it and simplify. Fourth sub question. What about fourth sub question? There P of A neither A, that is A dash nor end means intersection, B dash. Neither A nor B, that is not A and not B. What's the meaning of neither A nor B? Means not A and not B. Now again you are given that A and B are independent events. So we know that as per that result A dash and B dash are also independent. So that intersection becomes into. This again I'm emphasizing, this I could write because A dash and B dash are independent. This is because of which one? A dash and B dash are independent. If it is not, you cannot do like this. Then you need to use the De Morgan's. That is one of the earlier question we did it. If you just recall, let me show you that. See this. Here I could not write that multiplication. Here I need to use this concept because here you were not given the events where independent. See, here also I couldn't write multiplication. But what is the important one? You were given that the events are independent. So intersection equals to into. That we can write here because the events are independent. Otherwise, no. What is P of A dash? That is 1 minus P of A. This is 1 minus P of B. Now place the value. P of A is how much? 0.3. So this become 0.7. P of B is 6. So this become how much? 1 minus 0.6. That is 0.4. So this will be 0.28, which is required probability. The same concept, same this one, you could have done like these also without using concept of independent. A dash intersection B dash equals to P of A union B the whole dash. In case if the data, if you are not given, the events are independent. This you can write as 1 minus P of A union B and then use addition rule. This you know now further, you will get the same answer. But here you can use this because you were given that the events are independent. Otherwise, this method is already there using De Morgan's when you have both complement. Fine. Question number 12. That's a good question. A die is tossed thrice. Die is tossed 3 times. Actually, the same question we can do later on by binomial distribution, but let's do right now also. Now, in one try, that is in one toss, sample space is this. So total we have 6 outcomes that we know. And what's the question here? Probability of getting an odd number at least once. So we use actually complementary event here. Let A be an event that, odd number is obtained. Odd number is obtained in a single trial. So what is P of A? It will be obviously odd number means 1, 3, 5. So 3 by 6, which will be 1 by 2. Now here required probability equals to, required probability means what? Probability that odd number is obtained at least once. That is either 1 time or 2 times or all the 3 times. So we can use the concept of the complementary event and we can write 1 minus probability of getting odd number in no throw or in no toss. Is it? I've used the concept of complementary event. 1 minus probability of getting an odd number in no toss. It is as good as you can write the probability of getting what? Even number. Getting even number in 3 toss. Getting even number in 3 tosses or 3 times. in 3 toss. So 1 minus even number in 3 tosses. In 1 toss, what's the probability of getting odd number? 1 by 2. Even number is also 1 by 2. So here 1 by 2, 1 by 2, 1 by 2. So it will be 1 minus 1 by 8. So it will be 7 by 8. That is the required probability. I've used the concept of complementary event here. I repeat what I did. 1 minus probability of getting odd number in no toss. It is as good as the probability of getting even number in how many toss? 3 toss. What's the probability of getting even number in 1 toss? Half. 3, 4, 6 by 6, which is 1 by 2 as you did here. 1 by 2, 1 by 2. So we have finally 7 by 8. So, or you can do like these also. In one toss, you know either you have even number or odd number. Either even or odd. Either you have any one of this. So it may be even or odd. In the second toss, again even or odd. Even or odd. In third toss, again even or odd. Now I'm taking, you see, cross multiplication of all this. So one possibility is even, even, even. All are even. Then even, even, odd. Then you have even, odd, even. Then you have odd, even, even. Then you have now, let's take odd, odd, even. Then you have next odd, even, odd. Then you have even, odd, odd. And then here next possibility is all are odd. Fine. So total you have how many possibility? 3, 6 and 8. Total 8 possibilities. This is the main sample space here you can consider. Okay. So here required probability equals to upon 8. Now look at the question. What is asked in the question? Probability of getting odd number at least once. So odd should be 1 or more than 1. So 1, 2, 3, 4, 5, 6, 7. So 7 by 8. Here you have all even numbers. And which is 1 by 8. That's why you are getting 1 by 8 here. This is another way of doing the same question. If you feel that this is difficult, this is another way of writing the same question. Each trial I have considered as even and odd. And then I took the cross product. All are even, 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 odd, even, and so on. Here 1 time odd number, here 2 times odd number, and all are 3 odd numbers. At least 1 odd. So number of odd should be 1 or more than 1. So up to 3. This is the only one possibility. There all are which numbers? Even numbers. So 7 by 8. This is another way of answering the same question. Question number 13. You are given that 2 balls are drawn. With replacement. Such questions we did in the beginning. With replacement. That means selected one is placed in the box again. Out of how many? 10 black and 8 red. So total we have 18. Now when we write 2 are selected with replacement means 1 by 1. Remember the meaning of this one is 1 by 1 we do this. Okay, so here first sub question, both are red. Both are red means first one should be red and the second one should be red. So required probability means probability that the both are of the red color. How many red color? 8. So favorable outcome 8. Total 18. So 8 by 18. And this is multiplication. Actually here indirectly these are independent events. Second one is again red color. But the first selected is placed in the box. So again total number of red remains same 8 and total also 18 remains same. So this will be 4 by 9 into 4 by 9. So which will be 16 by 81. Is this clear to you? Why 8 by 18? Because you are going to take a red color. First one should be of which color? Red color. How many red color balls are there? 8. Total 18. So 8 by 18. Now before you draw the second one, the first one is already placed in the box because this is with replacement. So second time also you have 8 by 18 and therefore this is the required probability. What is the second sub question? The second sub question is first is black and the second is red. So here required probability equals to probability that it is of the red color and black color and the probability that it is of red color. Now what's the probability that the selected one is of the black color? Selected one is of the black color. It is given by how many black color? 10. So we will have here 10 by total how many? 18. And the selected one is placed in the box. So number of red or number of balls remain same, which is 18. But now it is of the red color. How many red color? 8. So we have here 5 by 9 into 4 by 9. So finally it is 20 by 81. Fine. What is the third sub question? One of them is black and the other one is red. Third sub question. So this is for you. Try. I'm sure you can do it. Question number 14. This is an important example. Probability of solving a problem independently by A and B is 1 by 2 and 1 by 3. So you are given that probability of A is 1 by 2, probability is B is also 1 by 2. And A and B are independent events. That's given to you. Independent event. In the question itself you are given. If they try to solve the problem independently, find the probability that the problem is solved. The first question is problem is solved. Now, can you tell me when the problem is solved? Problem is given to two students A and B. Problem is solved if at least one of them solve the problem. At least one of them or both, at least one of them solve the problem. It is not necessary that the problem should be solved by both. If either A solve the problem, then the problem is solved, or B solve the problem, then again the problem is solved. So here in the first question, required probability equals to probability of the event that at least one of them, either it is solved by A or B. So required probability is probability of A union B, not A intersection B, right? This is very important here. Conclusion. What is important conclusion? If at least one of them solve the problem, then the problem will be solved. And at least means what? Union. So in the first question, the problem will be solved if it is solved by at least one of them. So required probability is P of A union B. Now how do we write? P of A plus P of B minus P of A intersection B. But intersection we can write into because events are independent. So let's place the value. So here 1 by 2 plus here 1 by 3 minus 1 by 2 into 1 by 3. Okay, that is given to us. 1 by, here it is 1 by 3. So let's simplify this. This is nothing but 5 by 6 minus here 1 by 6. So finally we get the required probability, which is 4 by 6, which is 2 by 3. This is 4 by 6, which is 2 by 3. Okay. Now second question. What is the second question? Exactly one of them solve the problem. Exactly one of them solve the problem means what? Here required probability equals to either the problem is solved by A but not B and not B, Or means plus. Either it is solved by B but not A. Fine. This is very set theoretical notation, you know. This means A occurs but B do not occurs. This means B occurs but A do not occurs. That means occurrence of A only, here occurrence of B only. This means exactly one of the two students solved the problems. Solved by A but not B. Solved by B but not A. Or either this or this. These are the two possibilities. Now you know that A and B are independent. Therefore A and B dash are also independent. So intersection becomes into. Here also intersection becomes into. Why we could write intersection equals to into? Because events are independent. If A and B are independent events, then A and B dash and A dash and B are independent events. Now what is P of A? P of A you are given, that is nothing but how much? 1 by 2. What is P of B dash? Which is 1 minus 1 by 3. What is P of A dash? 1 minus P of A, which is 1 by 2. What is P of B, which is 1 by 3. So 1 by 2 into 3 minus 1, that is 2 by 3. This is half into 1 by 3. So here it will be 2 by 6. This is 1 by 6. So finally we'll get the 3 by 6, and which is just half. Question number 15. There one card is selected from 52 cards. From 52 cards that's given to you. There are 3 sub-questions. Everywhere you are asked to check whether events are independent or not. We'll do just second one. The other 2 you can try. In the second one, the event E, that is the selected card is black. Now how many black color cards? You know, 26. So what's the probability of E? That is 26 by total 52. That is just half. Right? We know that these 2 cards, if you observe these 2 here, the card of spade and club, these 2 cards are of black color, and the other 2 categories which are of diamond and heart, these cards are of red color. So 13, 13, 13, 13. So this is 26 of black color, this is 26 of red color. We know it, just to remind you. Okay, the next, what's this next question? Event F. Event F is nothing but the card is a king. You know, 1 from each of this. So probability of F will be, there are 4 kings, so 4 by 52, which is nothing but the 1 upon 13. Now to check whether events are independent or not, what we need to find? Probability of E intersection F. That is, card should be a king and it should be of black color. Intersection means both black and king. So it is from these 2 only. 1 from this and 1 king from this and 1 king from this. So it will be 2 by total 52 cards. So it will be 1 by 26. Now here find the product of these 2, P of E into P of F, which is 1 by 2 into 1 by 13. That is nothing but the 1 upon 26. So you can see that this and these are equal here. So therefore P of E into P of F equals to P of E intersection F. And therefore events E and F are independent. These are independent. Events E and F are independent. Okay. Question number next, which is 16. Let's see that. If you just read it, you will realize it is just a theoretical question. 60% students read Hindi newspaper. So probability that the students reading Hindi newspaper is 60 by 100. Okay, so you can just write 6 by 10. The probability that the students read English newspaper, which we are given 40 by 100, 40%. So 4 by 10. And 20% read both. Both means intersection. That is E intersection H. E intersection H. Both, which is 20 by here 100. So it is just 2 by 10. Fine. Both means intersection. We know it very well from the set theory. A student is selected at random. A student is selected at random. The first question is here. Find the probability that she read neither Hindi nor English newspaper. So probability that not Hindi, neither Hindi nor English, and not English. This is the required probability for the first question symbolically. Not Hindi and not English. So it is H intersection E with dash. Dash, you know, it means not. We have used number of times. Now here in the question you are not given that the events are independent, so you cannot write into. So what we do? We did it. You can use De Morgan's. So I'll write the whole dash. Fine. And then what we can do is, then we can write 1 minus probability of H union E. 1 minus probability of H union E. Now, how do you find the probability of H union E? For that, you have prepared addition rule. So, we can write this is equals to 1 minus P of H plus P of E minus P of H intersection E. So, 1 minus, just place the value. This is nothing but how much? 6 by 10 plus 4 by 10 minus 2 by 10. So this is nothing but here place the value. So 1 by 10 is the required probability. Second question. What is the second question there? In the second question, you are asked that she reads Hindi newspaper. Find the probability that she reads English newspaper. So here required probability equals to, symbolically, she read Hindi newspaper. So that event has already occurred. And find the probability that she read English newspaper. Read the question. Which event has already occurred? See, it is given that she reads Hindi newspaper. So this event has already occurred. Then find the probability that, comma means then usually. Then find that she reads English newspaper. Now how will do this conditional probability? You know, E intersection H upon probability of H. Just place the value. Important one is up to this. Then you can do. Third sub question. What about the third sub question? That you can answer now. In the third sub question, the required probability equals to, so here required probability equals to, she reads English newspaper. So event E has already occurred. Find the probability that she reads Hindi newspaper. So probability of H intersection E upon probability of E. Place the value and just simplify. So you will get the required answer. Okay. Now, as far as the last two MCQs concerned, let's see question number 17. Probability of obtaining an even number on each die when pair of dice is rolled. So, in a single throw of a die, 1, 2, 3, up to 6, even prime is 2 only. So 1 upon 6. Again, when you throw the second one, 1, 2, 3, 4, 5, 6. So for that again it is 1 upon 6. Now what's the question? Read the question. That a pair of dice is rolled, probability of getting even number on each one. So this and this. So required probability equals to product of this and this. So it will be just 1 by 36. So option D here. Last MCQs. Events A and B are independent if one of the option is true. So clearly you can see that B should be your answer. Why? See, look at, I'm just targeting B. A dash intersection B dash equals to, you have 1 minus P of A into 1 minus P of B. Okay. So what is this? You know this is P of A dash. What is this? This is nothing but the P of B dash. And A dash, B dash. You know this. And here your conclusion is A dash and B dash are independent. You know now one of the result, this A dash and B dash are independent only when A and B are independent. So B has to be your answer. It's the most appropriate answer. Even you can do like this also. Alternatively, what you can do is you start with this, simplify, and you can show that from this. Not a difficult task. Try. You can show this. Just try this. You can prove this, and this is true if events are independent. Right? I did it directly. You can show this one also alternatively. So try this. This is for you.